Okay, so this is the video for section 6.1, and we're going to be talking about how to find confidence intervals when the sample is large. Okay, so what we do is we use a point estimate. So what the point estimate is essentially, we take a sample from our population. It's going to be the mean of that sample. Okay. So one thing that I want to draw your attention to is that the sample statistic should be unbiased and have low variability. The standard error remember that formula is your sigma divided by the square root of n, where n stands for the number in your sample, is going to decrease as n increases. So what that means for us is the bigger the sample, the lower the standard error. And then one other thing that I want to remind you of is that the sample mean is going to be the sum of all of your values divided by your total. Okay, so let's go ahead and kick this off with an example. All right, so this example says we have an economics researcher who is collecting data about grocery store employees. And this list here represents a random sample of the number of hours worked by 40 employees from the grocery store in the county. Find a point estimate for the population mu. Okay, so what we're going to do is we are going to find the mean of this data. Okay, so you can plug this into the calculator. So I'm just going to refresh your memory on how to do that. So what you can do is you go to second stat, or I lied, just stat, and then you're going to click edit. And then here in this first list is where you're going to type in all of your data. So like 30, 26, yada, yada, yada. Okay. And once you have that, what you're going to do is you're going to click on stat again, and you're going to go over to calculate, and it's going to be one of our stats. So once you hit that, it's going to give you, and this is not correct because this data is not right, it's going to give you the sample mean of 7.4. Okay. So that's a way to do it in the calculator. You can also just simply add up all of these values here. That's probably a little bit faster than typing them all into the list. So we're going to find the mean by adding up all of our x's and dividing it by our total. Okay, so if I add up all of my x's, I'm going to get 1,184, and I'm going to divide that by my 40 employees, which is going to give me 29.6. Okay. All right. So the next thing that we're going to do is we're going to find an interval estimate. So what this is useful for is it's going to give you a range of values. And what we're going to learn how to do is we're going to learn how to make a confidence interval. Okay, and the confidence interval is going to pretty much be a standard with how confident we are that the population mean is going to be in between those two numbers. Okay, so what we're talking about with level of confidence is a certain percentage. So we have some common ones, and the most common ones that you're going to see in statistics are 90%, 95%, and 99%. Okay, those are the common ones that we're going to use, but those are not the only ones that we're going to use. And so we've done a couple of examples like this before where it gave you a value and it said, all right, what are the corresponding z values that go with 80% of the area under the curve or things like that. So let's go ahead and do an example. So I'm going to knock this example out. Okay, so for this example, they're giving us that we have 90% confidence, okay? So what I want you to think of, I want you to think of doing 1 minus 0.90, all right? And I'm doing 1 because the 90% is already, I moved it to a decimal, okay? So that means the area under the curve is going to be 1. So if I do 1 minus 0.9, I'm going to get 0.1. Okay, so what that is telling me is I've got 0.1 here and here, and I have 2 tails, so I'm going to divide that by 2. So I will get 0.05. Okay, so that means the data that, this is going to tell me that the area under the curve for this tail and this tail is going to be 0.05. So then what I can do is I can use my calculator or I can use the table to figure out what the corresponding z-value is. All right, so to do that, we're going to go to second vars, and we're going to do number 3 for inverse norm. So the area is 0.05, and I'm going to leave everything else the same. And I'm getting negative 1.645, so that means the corresponding z-value for here and here is positive and negative 1.645. Okay. All right, so that's the common one for 90%. I'm going to go ahead and write down the common one for 95% as well, just so you have that to reference. Okay, so for 95%, our z confidence level is going to be 1.96, and then for 99%, it's going to be 2.575. So I know typically we only use 2 decimal places when we deal with our z-scores, but for the 99% and the 90%, go ahead and use these 2 numbers, just because it's going to make our results a little bit more accurate. Okay. All right, next, we're going to have sampling error. And so our sampling error is going to be the difference between the point estimate and the actual population parameter, okay? So for us, that formula is going to look like x bar minus mu. Typically, we don't know the population parameter, and the x bar is going to vary from sample to sample. So margin of error. Okay, so margin of error is going to be the greatest possible distance between the point estimate and the value of the parameter that is estimating for the given level of confidence. Okay, so it's going to vary depending on what level of confidence that we're actually looking at. If we're looking at 90% versus 95% versus 99%, it's going to be different, okay? Things to keep in mind, your sample has to be random. And for this to work, you need to have a sample of at least 30 or greater, okay? So let's go ahead and think about our grocery store example and find the margin of error. So, okay, if you didn't remember, that example gave us 40 employees. So we had, I'm just going to write this down. We had 40 employees. Okay, and it's telling us that the population standard deviation is 7.9 hours. Okay, so in that case, sigma is 7.9, and we're going to use that for S in our formula. And since we are doing 95% confident, that z-score is going to be 1.96. Okay, so now that we have all of that, let's go ahead and write down our formula. All right, so our formula is E equals Z confidence level times standard deviation divided by the square root of n, okay? So we're going to do 1.96 times 7.9 divided by the square root of 40. And if I do that, I'm going to get roughly 2.4. So our summarizing sentence for this is, we are 95% confident that the margin of error for the population mean is about 2.4 hours. Okay, so you always want to use the phrasing that with the confidence level, that's how confident we are that this is the true case. All right, so now we're going to use our margin of error to create a confidence interval. So what we're going to do to create the confidence interval is, after we've found the error, we're going to add and subtract the error from our sample mean. And then that's going to give us the range for where our true population parameter should be. Okay, so let's go ahead and do an example. But before we do that, let me just run through all of the steps for you. Okay, so step number 1 is, first, you want to see if sigma is known, that the sample is random, and that the population is normally distributed, or that you have more than 30 in the sample. Then you're going to find your sample statistics. So we found our mean. Once you have the mean, you're going to find the z-score that corresponds with the confidence level. Okay, so as I mentioned before, you can use the table for this. You can also use your calculator. So remember the calculator, it's going to be second vars, and then inverse norm. You need to find the margin of error, and then you're going to use that margin of error to add and subtract to get the endpoints of your confidence interval. Okay. And just keep in mind, it's always going to be the smaller number here and then the larger number here. Okay, so that's just convention with how we write it. All right, so our grocery store example, let's find the confidence interval for that. Okay, so hopefully you remember we had n was 40, our sigma was 7.9, which we used for S. We had an error of about 2.4 that we found. We found the mean to be 29.6. I think that was all of the information. Oh yeah, 95% confident is 1.96. All right, so that's everything that we need. So what we're going to do, since we already did most of the work for this problem, is we just need to now find the confidence interval. Okay, so here's my formula. I'm going to subtract and add my margin of error to my 29.6. So minus 2.4 and 29.6 plus 2.4 will give us 27.2 and 32. All right, so we're just going to write our summarizing sentence. So what we're going to say is we are 95% confident that the population mean is between 27.2 and 32 hours. Okay. All right. So, wouldn't it be great if we could use our calculator to figure this out? And you're probably thinking, yeah, why didn't you show me that to begin with? Because I want you to appreciate the math. That's why. Okay, so in this case, we're doing the same problem, but now we're doing a 99% confidence interval. Okay, so what you're gonna do, let me write down the calculator steps first. So you're gonna click on stats and then tests and then Z interval. Now, when you click there, it's gonna give you two different options. It's gonna ask you what your input is. And you have data or list as an option. So when you have data, this means like you actually already know the mean, the standard deviation, et cetera, et cetera. You know all of that stuff. When you have a list, this is when you actually type the list in to find that information, okay? So you're gonna use the data when you know the information, and you're gonna use the list when you have data and you need to find the mean and the standard deviation of the sample, okay? Okay, so let's go ahead and do this problem. So we're gonna use stats because we already know all of the information. Oh, I think I said this backwards. Okay, I did totally say this backwards. All right, rewind. Okay, so obviously I can't talk and write at the same time. All right, so data, you're gonna use this when you have a list. So this is like when you type it in to find the standard deviation. Stats is when you already have that information. You have all the statistical pieces. So like the mean, the standard deviation, etc. Okay. So we're going to use stats because we already know this information. Okay. So our sigma that we had was 7.9. Okay. We had our n was 40. We had X bar was 29 point, what was it? 29.6. Okay, so go ahead and hit stats, test, Z interval, and then we're gonna click on stats, and then you're gonna type in the information where it is needed. So 7.9 was our sigma, our mean was 29.6, N is 40, and then our confidence level was 0.99. And then once you have all of that typed in, you can then hit enter and it'll calculate it for you. And I got 26.383 and 32.817. So if we were going to write a sentence for this one, we would say we are 99% confident that the mean of the population is between 26.383 and 32.817 hours. Okay. So you probably noticed that the numbers for this is actually wider than our previous example. So as your confidence level goes up, what you're going to notice is the range of numbers that included gets wider, because the more confident you are, the more you have to include to make sure you cover all of the bases, essentially. All right, let's do another problem. Okay, so we have a college admissions director, and the college admissions director wants to estimate the mean age of all the students currently enrolled in a random sample of 20 students. Okay, so that's my N. N is 20. The mean age is found to be 22.9 years. So they gave me my X bar is 22.9. From the past studies, the standard deviation is known to be about 1.5 years. Assume the population is normally distributed. Construct a 90% confidence interval of the mean population age. Okay, so since we're doing 90% confidence, that is telling me that my Z value is going to be 1.645. So the first thing that I'm going to do is I'm going to find my error. Okay. So my error, remember that formula is Z value times sigma divided by the square root of N. All right, so 1.645 times 1.5 divided by the square root of 20. I'm going to get about 0.55. All right, so once I have that 0.55, I'm going to subtract and add that to my mean. So 22.9 minus 0.55. And I keep forgetting my second sign. 22.9 plus 0.55, which will give me 22.35 and 23.45. All right, so let's write our sentence. So our sentence is, we are 90% confident that the mean age of college students is between 22.35 and 23.45 years. Okay. Okay. So just a few other things to keep in mind. So one of the things to note is your population mean is a fixed number. And it can either be in your confidence interval or not in your confidence interval, which is why we use the phrase that we are a certain amount of confident that it is between here and here, okay? So you're never gonna say there's a 90% probability. What you're gonna do is you're gonna say we are 90% confident that the number lies within this range, okay? So the reason why this works, and I'm going to show you another picture that I think will help clear this. So I feel like this is a really good representation. So what these horizontal segments are is they are 90% confidence intervals for different samples. So what's happening is the population mean is here, and 9 out of 10 of these confidence intervals actually contain the population. Okay, so sometimes it happens that this confidence interval doesn't contain it, which is why we're only 90% confident. We're never going to be 100% confident that something happened. Okay, so this is a really nice picture to demonstrate, because this guy right here does not contain our population mean. Okay, so sometimes we want to work backwards. And so we want to find out the sample size. And we're going to do this based on a confidence level and a margin of error. Okay. So one thing to keep in mind is if your sigma is not known, you're going to estimate it using the standard deviation provided. Okay. Now make sure your sample again has more than 30 members. We're going to talk about what happens when we have smaller samples in a second. Okay, so let's go ahead and knock this out with an example. All right, so we want to estimate the mean number of hours worked by grocery store employees. How many users must be included in the sample if we want to be 95% confident that the sample mean is within 2 hours of the population mean? Assume the sample standard deviation is about 7.9. Okay, so the first thing that I'm going to do is I'm going to write down my formula to see what I need for this. So we have N equals z-score sigma E squared. Now, essentially, this formula that we have was the previous formula that we were using. It's just rearranged for N instead. So they did all the work for you. You don't have to rearrange the other one. Okay, so let's go ahead and see what we have. We are using 95% confident. So remember, that is going to be 1.96. The sample standard deviation, we're going to use that for sigma, is 7.9. And within 2 hours, that is actually going to be my error in this case. Okay, so let's just go ahead and plug in. So we're going to say 1.96 times 7.9 divided by 2 squared. Make sure you do the squared. For some reason, I keep forgetting to do that. All right, so I got about 59.9. And whenever you're doing these problems, you're always going to round up. Okay, even if whatever the number you get is not telling you to round up, you're rounding up to the nearest whole number. So I'm going to get 60 people. Okay. All right.